In this video, we're going to look at translations in plane space using vectors. So whenever you have a translation being performed in plane space, you will be given a vector, or you may have to draw the vector. And if you remember, a vector is a quantity that has length and direction. So it's going to tell you which direction to move and how far to move it. So the first thing I want to do is draw in the vectors in these pictures. So let's make an assumption here to start. Our dotted figures will be our pre-image. So dotted will be the pre-image when I'm looking at the different pictures, and then the solid pictures are going to be the image, so the result after you do the translation. So when we draw in the vectors, we have, starting at the pre-image, the dotted, we want to look at, okay, so if I start at this point here, where does it go? It ends up right there at that point. Same thing with this, it's going to end up at this point. And I want to actually connect all of these vectors because I want you to see that I want you to see the properties of them. So if you look, here's all of the pre-image points. They're getting mapped to these image points. So you can see that these vectors look like they're the same length, as well as they're all going in the same direction, and they're parallel to each other. So that's going to be important when we go to construct a translation in plane space. If I look at this example here, now I'm starting at the left side. This is moving to this point. This one will be moving to that point. This moves to this. And remember, vectors don't go on forever. They do have length. So the arrowheads are just representing the direction that it's moving, but they do stop. So those vectors, again, you can see that they're the same distance. They're going the same direction. They're parallel to each other. So that's important. And then the last one I want to look at is this picture here. So starting at the dotted, so this one here will end up at that, so this point will end up right here. This point will end up down here, which is kind of weird to look at. And then this will end up at this point. So really you have two separate vectors here, this point mapping to that point, and then this point mapping to this vertex there. So again, vectors are the same direction, they're the same length, they're all parallel to each other. So some properties about when we do a translation is that every single pre-image point is going to use the same vector to do the translation. So let's write that down below here. So one of the conclusions is that every pre-image point uses, every pre-image point uses the same vector. And then remember that the vectors are going to have, they're going to be parallel to each other. So I'm going to add that. So vectors will be parallel. The vectors will be the same, will be going in the same direction. So vectors go in the same direction. And then the last thing I wanted that we talked about was that the vectors are all the same length. So vectors have the same length. So when we say, so basically when I write this, every pre-image point uses the same vector. Well, the same vector, these are the things that we care about, that the vectors are parallel to each other, that they go in the same direction, and that they have the same length. So each pre-image point has these three properties when we're talking about using the same vector. So if we go to the next page, we're actually going to do a construction. So here are your steps for how to construct a translation. So I'm going to just kind of walk through these as we go through the construction. So the first thing we have to make sure that we do is we have to identify the vector, because that tells you how you're moving. On a coordinate plane, it'll just tell you, okay, move right 2, up 1. But if I'm in plane space, meaning there's no graph, I can't just tell you to take this segment here and move right to up 1 because there's no measurement for you to count. So instead, we give you this vector. So if you look, it says use your compass and straightage to apply T, and a little subscript here is AB. That AB is the vector. So that tells you the distance and direction to go. So this means use vector AB to decide, I'm going to move this compass, which direction, to decide which direction and distance to use for your translation. So I have to measure the vector AB. That's going to tell me how far I'm going to move. And then the arrow tells me which direction. And remember, we always have to move parallel to this. So the first thing we're going to do is we're going to take this segment, P1, P2. So don't worry about the subscripts here, P1 and P2. It just represents that there's two different letters. If you wanted to make this segment B, or let's not use B because we already have B, but like CD, that's totally fine. It's the same thing. So if I'm going to do this, I need to take P, and I need to take P1, and I need to take P2. I'm going to put coordinates on those, or points on those. And I'm going to make sure that I measure the distance of the vector. So that's my first thing I have to do, because I need to take those points, and I need to make them go the same distance as vector AB. So I'm going to measure this vector, which means I'm putting a little arc on there to represent I'm measuring. And then what I'm going to do is I'm going to go to these points here, and I'm going to just draw a arc, or you could go all the way around. You can do circles if you want, all the way around those points, because that's the distance of the vector that you need to travel. So then I'm going to do the same thing down here. So you can just make an arc in the direction that you're going to end up going, but you might want to just make circles and you don't have to worry about it. So that's your first step, is all of the points on these circles are the distance of vector AB. Then what I need to do is I need to move the same direction as AB. So it's going to the right, but I need to make sure that I'm parallel to it. So what I'm going to do is I'm going to take my compass, and I'm going to measure from point A. So starting at point A, I'm going to measure to P1. So I'm measuring this distance here. I'm going to mark an arc so you know I measured. And then I need to take P1 and I need to translate it so that it ends up going the same direction to get to B. So to make it go the same direction as this vector, you're just going to trace this vector. So see how I'm just taking the edge, I'm tracing along until I get to the endpoint. Once I get to the endpoint, I then take and I mark that intersection. And then I'm going to do the same thing down here. So from A, I'm going to measure until I get to P2. Mark that with an arc. And now I'm going to take the compass and I'm going to slide it down. So I'm going the same direction as vector AB, following the arrow. Once I'm done, I mark that arc. And now I can label these. So I have, this is going to be, this intersection will be P1 prime. This intersection will be what happened when I translated P2, so that'll be P2 prime. I can go ahead and connect them, and that's my image. So it should look like the segment stayed the same length. It became the same distance away as the length of AB. So that distance between those points is the length of AB. And it went the same direction as AB to the right. And that's it.